Hello students, this lesson is on geometric series. And with geometric series we have two types. We have a finite series, and that means that it ends. And then we have an infinite series that does not end. Let's first look at some examples of a finite series. So this particular example, we are going to evaluate the sum. Now, because it is a finite series, it does end, but they don't necessarily have to have all of the terms written there. So you can see in this first example, they've only written the first 4 terms, but it's telling me that it ends after 6 terms. So that means that you will have a value of n. So here's the formula for the finite series. It's S sub n equals a sub 1, which is your first term, times 1 minus the r to the n power over 1 minus r. And this is on your formula card, so make sure that you're getting it from that. Now let's go ahead and plug in what we know. The first thing that I need to do is I need to figure out what my r is. Now remember, since this is a geometric series, that means that you're multiplying in between the numbers. So you can see that from 2 to 6 we had to multiply by 3, and that should be the same between the next two numbers. So 6 times 3 gives you 18, and then 18 times 3 gives you 54, and so on. So our rate, or our r, the ratio, is 3. Okay, let's go ahead and plug in what we have here. So our first term is 2, parentheses, 1 minus the 3 to the n power, and they told us that our n power is 6, so we're going to plug in a 6, and it's all over 1 minus 3. Now if you're going to enter this in on your calculator, I highly recommend you doing just some basic math before you enter it in, because if you enter it in just like this, remember your calculator is going to just go by the order of operations, or if you go ahead and put it in as a fraction, but since we're using the scientific calculators, you might want to put a parenthesis around the 1 minus 3 so that it will divide everything by 1 minus 3, which is negative 2. So when you type this into the scientific calculator, you get that it is 728. Okay, and again, let me point out the reason why we summed it is because it said evaluate. So that's kind of a key word for you to know that you are going to use a summation formula. Okay, let's look at example 2. So let's first figure out what our r is. What multiplied by 3 gives you negative 6? Well, that would be a negative 2. And then just double check it. Negative 6 times a negative 2 gives you 12, and then 12 times a negative 2 gives you negative 24. So it does look like our r is negative 2. Alright, so let's plug it into the formula. S sub 8, we can go ahead and put an 8 there because that is, we're trying to find the sum of the 8 terms. A sub 1 is 3 times 1 minus, now this is very tricky. When your r is a negative, you need to leave that minus there and then put the r that's negative in parentheses, and now you're raising that up to an 8 power. It's very important that you never change that to a positive, because the order of operations say that I'm going to raise negative 2 to the 8th power, and then I'm going to subtract it from 1. So this is over 1 minus a negative 2. Now here, minus a negative, I can change that. But it's just very important, don't ever change this. So never change this one to a positive. Never change that because you're raising the negative to a power before you subtract it. Okay? So if you do this on your calculator, you should get negative 255. Okay, same set of examples. This is a series. We have 4 terms, and I want you to go ahead and evaluate it. So try it on your own, and then press play when you're ready to check your answer. Okay, you should have gotten the answer 40 over 81. On this one, I highly recommend you doing just a little bit of math at a time when you're entering it in on the calculator, because again, with these scientific notation calculators, you have to be very careful of how much you enter in, because it is going to go with the order of operations. So you might consider doing the inside of the parentheses first on your calculator, and then writing that answer down, multiplying it by 1/3, and then dividing it by the 1 minus 1/3. Okay? Okay, now let's look at the infinite series. We have 2 types of infinite series, and they're converges or diverges. When it converges, what that means is that it approaches 0. So the series is going to get smaller. It's going to approach 0. Okay, another thing that you want to think of when you say the word converges, that means that it is shrinking. The series is getting smaller, the numbers are getting smaller. And when it converges, think of it this way. If it's getting closer to 0, and so you're adding these numbers, and you keep adding the numbers as they get closer to 0, when you get to the end of the series, the numbers are getting infinitesimally small. It means that, like, maybe now you're going to add something with the weight of like a paper clip. Well, then the next one you're going to add something with the weight of like a little piece of lead. The next time you're going to add something with just like the weight of a hair. So if you think about it, as you're adding something that is really, really small, it's not really changing the sum that much. So the converges series, they do have a sum. They have a sum. Convergent series, they have a sum. This is very important, and you just need to think about it that way. As it's approaching 0, you keep adding something that is really, really small. So it's not changing the sum that much. Now, when you have a divergent or a diverges series, it diverges, that means that it is getting larger or it's going away from 0. Okay, it's growing. And if it's growing, then you're continually adding a number that's getting larger and larger. And so because it does not end, it's an infinite series, you're going to keep adding a larger number. And so for divergent series, they have no sum. Has no sum. So just think of it this way. If you're adding something big, well, you can't figure out what the sum is, because as soon as you add one number, you're going to add another number, and it's just going to keep on going. But when it converges, it approaches 0. You're adding small numbers to where the smaller that number gets, you will actually end up with a sum, because it's not going to change the amount by adding just a super small number. All right, so let's just look at these examples. We're just going to state if the series converges or diverges, and does it have a sum? Well, in this first example, you can see that it is getting smaller. The numbers are getting smaller, so that means that it converges. And if it converges, then it does have a sum. So it might be something that you're just going to have to memorize. In example 2, it's getting larger. So it diverges. Which means that it doesn't have a sum. So it has no sum. And then in this last example, it goes from 200 to negative 50 to 12.5. But you can see that the numbers, even though they're kind of bouncing back and forth, they are getting smaller. So this one is considered converges. And yes, it has a sum. Okay, so we're going to stop there. I just want you to get an idea of the two different types of geometric series. And then we'll talk about how to find the sum of an infinite series when it converges. Okay, so that's all for tonight. Fill out your WISC and come to class ready to work.